When early man looked to the heavens at night, he was confronted by an astonishing array of lights. Although the sight was available most nights, the stars were mysterious, open to any speculation as to their purpose and origin.
Most of these lights seem to be fixed in their positions relative to one another, as though glued to an invisible sphere around the Earth. Early people grouped them into patterns called constellations. As civilizations developed, sailors learned to count on the stars to guide them on their great voyages. But early maps of the sky included some lights that did not remain in fixed positions. They wandered across the sky, weaving intricate patterns between constellations. The ancient Greeks called these curious stars planets, which simply meant wanderers. They believed these wanderers were the shepherds of the gods, keeping watch over the stars that shone in the evening sky. The ancients recognized 5 planets. They called them by the names of their gods: Mercury, Venus, Mars, Jupiter, and Saturn. The planets stood out not only because they wandered, but also because their bright light held steady without twinkling. Later, with the aid of the telescope, astronomers found that stars stayed as points of light, but planets resolved into disks. We now understand that points of light can be disturbed by Earth's moving atmosphere, where light across a disk cannot. More interesting still was the planets had surface features. Astronomers could now glimpse into other worlds, worlds so strange and beautiful that the fires of human imagination have burned ever since.
And what about this universe next door? What have we learned of the planets in the nearly 400 years since the invention of the telescope? Why is their study important to us? And how can our knowledge of each of them help us to solve problems here on Earth?
Roughly 5 billion years ago, the solar system as we know it didn't exist. The makings of it were there all right, but in the form of gas and dust that began to collect and bind together. Surprisingly, most of this gas and dust came from worlds and stars that had lived and died billions of years before.
Here on Earth, we're very familiar with the cycle of life. Creatures are born, they live, and then eventually die, and the bodies of these living things decompose in the ground and provide the raw materials for new life. Just as dead leaves fertilize the ground for new trees, so do the deaths of stars fertilize the heavens for new stars and planets. There's a significant difference, however. When leaves fall to the ground and die, they do so relatively quietly, but when stars die, they can be spectacular. Among the most spectacular is the rare event called a supernova.
Over the course of its life, a star is powered by fusion. That is, the building up of heavier elements from lighter elements, beginning primarily with hydrogen, building up to helium, and then carbon and oxygen. And the fusion process can build up materials as heavy as iron. When that happens, when the star has a large core of iron, then the fusion process can no longer power the star. And this is when you have additional processes like gravitational collapse that causes a supernova explosion. And it's in the process of that gravitational collapse and the new supernova explosion that you form the elements heavier than iron.
In the different layers of the sun as it explodes, the extremely violent shock wave crushes basic elements into more complex ones. Gold, silver, platinum, lead, uranium. In fact, all the heavy elements in the universe owe their existence to the powerful squeeze and heat of the death throes of a star.
This means that the gold contained within the ring around your finger or the chain you wear around your neck was created deep within an exploding sun over 5 billion years ago.
The exploding star flies apart, ejecting newly synthesized heavy elements at 7 million miles an hour into space, along with a vast amount of hydrogen and helium. Eventually, the new substances mingle with the remains of other dead stars. Gravity, the universal force, draws the gas and dust together into swirling masses. In the case of our solar system, the bulk of the material, mostly hydrogen, collected at the center of the swirling cloud. When sufficient material had accumulated, its crushing gravity ignited nuclear fusion. Our sun was born, and its light burst forth. Other swirling masses collected at regular intervals away from the center and formed the planets. The new sun began to throw off a powerful stream of particles called the solar wind. The force of this wind stripped the inner planets of their lighter gases. Mercury, the closest planet to the sun, lost its entire atmosphere. Today, it's as airless as our moon.
Big enough planets can have enough gravitational oomph, they have enough mass, so they can hold on to things well enough, with enough gravity, they can hold those gases close to the planet, forming atmospheres. So Venus and Earth are big enough to have retained large atmospheres.
Named for the messenger of the gods, Mercury circles the sun every 88 Earth days. Mercury's closeness to the sun makes it difficult to observe. Mercury can only be shielded from the sun's overwhelming glare during the brief time 2 hours before sunrise or after sunset. That's why it's known as the morning and evening star. Though only about 1/3 the size of Earth, Mercury nonetheless is a rather heavy planet. Like Earth, it has an iron core. Gravity on the planet is about 1/3 as strong as on Earth, so that a 150-pound human would weigh only about 50 pounds on Mercury. Mercury is a very hostile place. During its long day, which lasts 56 Earth days, the temperature can reach as high as 700 degrees. In the night, the temperature can drop to 300 below zero. The surface of Mercury looks very much like the surface of the Moon. It is extremely pockmarked by craters. It has both mountain ranges and basins with evidence of some early volcanic activity. But today, magnetic data shows that Mercury's core has cooled. Also, its fractured, wrinkled surface indicates it may be shrinking, contracting as its internal heat is lost. With no atmosphere, blazingly hot days, and frozen nights, Mercury is one of the least hospitable places in the solar system. Humans may find it useful for its minerals, for scientific study, and for collecting energy from the sun, but not for a stroll on the surface.